Hi, everyone. Welcome back to the 2021 STIR/SHAKEN Virtual Summit. My name is Mark Robbins. I'm President and Managing Director of the SIP Forum. And I'd like to welcome all of you to our second session of the day on Enterprise STIR/SHAKEN Identity Management using distributed ledger technology. And I'd like to introduce our speakers today. We've got Ian Deacon, who's Principal Technologist at Addis. Hey, Ian, how are you?
Hi, how are you doing? Good, thank you very much, Mark.
Also, we've got Mark Himelfarb, who's Chief Technology Officer at First Orion. Hey, Mark.
Hi, Mark. Hi there.
And also Julie Fowler, who's Director of Solutions Design and Technical Sales at First Orion. Hey, Julie, welcome.
Hello, everyone. Mark.
So, Mark, I believe you're the first to present, so I'm going to turn over the virtual podium to you and have a great session.
Thank you, Mark.
Thank you.
Hi, everyone. It's a pleasure to virtually meet you. I'd like to take a second to talk a little bit about First Orion, what we do, and how we are participating in the ecosystem today. You probably know us as a leader in call protection solutions. We have a number of customers in the United States and Europe, including Tier 1 customers. We provide call protection services for those. We're also a STIR/SHAKEN solution vendor. We have a full range of capabilities for attestation verification and also key custodianship. And we have some very custom elements that we've developed over time as we are working to service our customers. We provide both in-network and SaaS-based implementations of the STIR/SHAKEN solutions. The other part of our business, which is really essential to us as we understand this is a bigger part of the new world we're living in, is the call enhancement. Branded calling solutions. Those are essential to us. We have a number of key enterprise customers in the US around the globe, and we provide them with call branding and call enhancement solutions. We continue to spend a lot of efforts in emerging technologies, and STIR/SHAKEN and RCD are a special interest to us, and we're active specifically in the Addis efforts to promote and enhance the existing ecosystem, include RCD and other emerging technologies in the future. And finally, enterprise identity is really essential and interesting to us. We work a lot with enterprises, nature of our business, and so we are involved in the enterprise identity DLT working group and are pivotal in building and maintaining hosting the solution and the interfaces for this proof of concept. Ian, back to you.
Thank you. Well, I think most people that are involved in STIR/SHAKEN already know about this, but I just wanted to put the context on the DLT initiative that started within Addis. As most of you know, we're a North American SDO. We have 150 members representing the boards across the ecosystem of carriers and ICT, and we collaborate with the industry and with government to provide solutions to problems of standardization work. Primarily, I suppose the strategic initiative group within Addis looks at a number of emerging technologies and emerging trends that are happening in the industry and how we need to actually adapt ICT and communications going forward towards either enhancing or be prepared for that new technology. And DLT group was one of the initiatives that was set up actually back in 2018, where this project started from. And here's actually just the board level members, some of the brands some of you might recognize. So I just wanted to take a little time to actually maybe just explain blockchain distributed ledger technology. Distributed ledger technology is actually, it's a family of technologies that includes blockchain in itself. That it's built on proven technologies, including distributed computing, cryptography, encryption, and hashing. And that allows you to actually secure information and distribute it in real time across a network of nodes. Blockchain is one of these types of distributed ledgers, and it organizes data in blocks that are verified, and it only appends each block as information is added to the blockchain. And cryptocurrencies such as Bitcoin that pioneered this technology has been operating for over 10 years now, and actually, I suppose a testament to its security is that it's not been hacked in those 10 years. So it's built on cryptography, and it's proven technology. But again, just to explain the difference between what's public versus a private blockchain DLT, you can have ledgers that are public, and typically they would be the public blockchains like Bitcoin, which allows anyone to connect to the network and make transactions, and everyone has a full copy of the ledger. They can see the information, and anyone can access the node. And typically they have what is called a consensus mechanism to validate those transactions, and typically they are slow. There's transactions fees involved, and you do get these consensus bottlenecks, which is it allows maybe 10 minutes for validation of information, but it's still very secure, and it has applications, as we've seen with Bitcoin cryptocurrency, for people to exchange value transfer with someone anywhere in the world that they don't know anything about securely. But you've also got private permissioned ledgers, and these are typical within the enterprise environment that limits really contribution and access to that DLT for specific types of users, and their permission to only do certain things on there, and access to view the records can be restricted either to everyone or depending on their privileges. And these types of protocols, these DLTs, are very fast. You've got immediate confirmations, you've zero transaction fees, and they're highly scalable, for huge applications. And here's some examples of DLT being used and blockchain really across the telecom industry today and at scale. AT&T, they've actually got a business services, and they're providing blockchain technology to help companies to transform their businesses today. Verizon has the Verizon ID, and it's creating a true digital identity using blockchain, and this allows the users to actually have both physical and digital documents stored, including credit cards, insurance details, education, professional credentials, so that they can keep them safe, and they're secured through encryption using biometrics as well to make them tamper resistant. Comcast has collaborated with the media industry to provide a blockchain for customer insights, and that's a collaboration across a number of brands that you might know there, with NBC, Disney, Cox Communications, etc. Cineverse has actually provided a real-time interconnect clearance and settlement platform using blockchain, and that allows, as I say, real-time settlement between two carriers in real time. And the last one, which is interesting, and the reason I mention it is this is actually a service in Canada where citizens actually have their own identity now available, and it's a self-sovereign identity that allows them to actually prove who they are, to access government and even public services online, either in person to prove themselves, or over the phone, or on the internet as well. And digital services and actually identity services for citizens are now becoming prevalent using what is called self-sovereign identity. So we now have a poll question.
Okay, the question is, have any of you have any experience of working with blockchain or DLT? And your choices are none at all, or private cryptocurrency investment, enterprise application at my company, and the last choice is both B and C. We'll give folks about another 30 seconds to vote, and then we'll share the results. Okay, 75% indicate none at all. 18% indicate private cryptocurrency investment. 4% enterprise application at their company, and 4% indicate both B and C. Interesting.
So obviously, people are still yet to experience DLT and blockchain. It's still a technology that people need to get used to. So I just want to give you the background now, really, about the start of the DLT initiative within ATIS. It was a DLT focus group, as I say, it was established in 2018, and the objective was to look to see what were the real-world challenges facing the communication industry at that time that could be applied to DLT. And, you know, we asked our members to bring forward a number of different use cases, and we took a deep dive into those use cases and looked to see if we could validate them in a way that we saw that we could add value and something that would be tangible, where the goal was really that we could actually have a proof of concept that could validate that thesis and show to the industry, you know, how DLT could be applied using what is, I suppose, core to its functionality and its capabilities around immutability, trust, authentication, and identity. And out of that, actually, the use case that was decided, which was, you know, I know it's moved on since that time, that, you know, there was challenges around, you know, enterprises providing true attestation of their telephone number in a multi-homing scenario, that, you know, that you know, effective vetting of an enterprise was creating a barrier to entry. There was no universal process for that, and difficulties, as I say, to attest to a telephone number if the telephone number was provided by one carrier and the other carrier didn't know anything about that relationship when a call was being placed in a multi-homing scenario. So that was the basis of the use case that was decided upon within the group to actually examine and look into further. So we just have another poll question there.
Okay, the question is, what percentage of your enterprise customers would be small enterprise businesses, less than 50 employees? First choice is I don't know. We don't provide enterprise calling numbers. Second choice is more than 50% are small businesses. And the third choice is less than 20% are small businesses. We'll give folks a few more seconds to respond. %33 indicate they don't know. 47% indicate more than 50%, and 21% less than 20%.
Interesting. Thank you. So the approach that the focus group took to actually analyzing this use case in more detail was really to actually look at both the business and technical process and try and define the service, how it would apply to DLT. So we created a holistic view of really all of the stakeholders that were impacted by this problem, and that was just not really just the carriers within the call validation path. This was everyone involved, from TNs, number providers, resellers, BPOs, KYC vetters as well, and try and identify the functions that were performed by each of those stakeholders, to define those functions and how they could be applied on DLT to enhance the service, and obviously primarily to leverage and enhance the shaken service to have better verification of the telephone numbers and callers that were placing calls with their telephone numbers. And also what we looked to do was to see how we could it could be applied to identify efficiencies or potentially inefficiencies that DLT could improve efficiencies within the process in terms of assigning telephone numbers and knowing who that caller was. And again, looking at where there was potential for additional value generation and potentially new business models as well. Now, we created a white paper as a result of that work, which was published at the end of 2019. It's the I-76 document, and it's Enterprise Identity Distributed Ledger for Authenticated Caller Use Cases. And that defines the environment, how we defined it, and the use cases. So that was the basis then for us to move forward to see was it relevant to actually develop a proof of concept. So we developed actually an enterprise identity subgroup for those interested in actually advancing that concept to develop a proof of concept. And we had a number of companies participate in that across all aspects of the stakeholders, really. From the bottom up, really, there was Metaswitch is now Microsoft, TNS, and First Orion looking at the call reputation and attestation level. T-Mobile and Charter Communications looking at the carrier perspective and interworking for shaking. Numerical advising on the KYC vetting process. Two organizations that were involved in DLT, both IBM and IOTA, to give us information about how this could be mapped onto, a DLT to perform the functions that we required. The TN number management with Intelliquent and Somos on the toll-free number side, and then First Orion on the call signing and validation aspects of it as well. So all of these companies collaborated into defining the detail around the proof of concept, what it should provide, and how it should be integrated with Shaken to provide enterprise attestation. So as I was mentioning before, the technology that we chose to use was self-sovereign identity. It's a W3C standard based around what is called a decentralized identifier. And what that means is now that the identifier is actually created by the enterprise themselves, and they create their own identity, and they publish the public key to their identity on the DLT. And how that then gets vetted is that then a KYC vetter, through an out-of-band process, they would actually prove who they are and with their identity. And once the KYC vetter is satisfied that this is the business entity that says they are, and with the RCD claims that they're looking to use, they can sign a verifiable credential, which is proof of their identity and they're authentic. They say who they say they are, and their brand names, etc., included with the RCD claims. And equally then, when they want to use a telephone number and they go to look to acquire a telephone number from a TNSP or a TN reseller, then the authorization to use that telephone number is assigned proof as a verifiable credential within that DID document as well. So now within the one DID document that's on the DLT, we know the identity of the caller based on their decentralized identifier. As you'll see in a moment, it's based on a UID, and they've also got proofs of who they are and the rights to use the number that they're using as well. Oops, sorry. So with that in mind, anyone that's connected onto the DLT, when someone places a call and they sign it with their identity, then anyone in the call path can interrogate the DLT and actually look up the DID and actually prove that they're vetted and their RCD claims that they're using, and also that they've right to use a telephone number. And equally, if the identity was revoked for any reason, then anyone in the call path can see that that identity is now actually revoked. And equally, if the telephone number was taken back and not allowed to be used by that enterprise identity, that will be updated immediately as well. Sorry. Oh. So we have another poll question.
Okay, the question is, do you use an outsourced organization to KYC vet enterprise business when onboarding them? The answers are I don't know, we don't provide enterprise calling numbers. Second choice is no, it's all done internally. Third choice is yes. Give you folks got 20 seconds or so to respond. Okay, 38% don't know. 52% say no, it's all done internally, and 10% indicate yes.
Interesting. So as part of the process that we looked at in terms of trying to model the service on DLT, we needed to do two things. One, which was what was the trust hierarchy or the governance and trust hierarchy, who was going to verify which actor on the network. So we had to model who are the actors, and as we say, we have a trust authority, which is kind of the highest level of trust authority. That might be akin to the STI GA today. And obviously we've got service providers, OSPs, TSPs, TNSPs, KYC vetters, and then we've got the brands, the BPOs and TM resellers. And then we looked at what was the relevant trust hierarchy for who was going to vet who. And you can see here on the left is that the trust authority would vet and verify TNSPs, who are the highest level numbering providers in the system, and the KYC vetters. And the KYC vetters would then vet the brands and the BPOs, the call centers, the resellers. And that was important in terms of how we would actually model the business logic for the service. And then on the TN authorization side, we had to model what was the allocation of telephone numbers to TNSPs, the assignment of those numbers then by the TNSP to either TNRs or directly to a brand, and then the modeling of delegation from a TNR to a brand, and then further maybe to a BPO as well. So we modeled all of that because it was important to know how, again, within the business logic, how TNs would actually cascade through that process, and also how they would be taken back as well in the case of, you know, a telephone number being taken back. An example might be a port from one TNSP to another TNSP, that obviously then it would need to actually, we don't need to know which was the root TNSP that the number needed to actually be disconnected from and then connected to the new one. So we'd have to rebuild the chain of trust in that context. And sorry, another poll.
Okay, the question is, what type of system do you use to manage telephone number allocations to customers? Third-party database provider, internal database system, a combination of internal and external databases. And the last choice is I don't know, we don't provide enterprise calling numbers. Give folks about another 30 seconds to respond. Okay, 4% indicate third-party database provider, 50% internal database system, 24% a combination of internal and external databases, and 22% don't know or don't provide enterprise calling numbers.
Okay, thank you, Mark. I promised that is the last poll question. So it was just to get a feel for kind of people's, what people were doing and their interests in this topic. So the last portion of what we looked to model was how the enterprise was going to actually pass the information around its identity to the OSP, and how the OSP then was going to verify that from the DLT, so that the STIAS would have information to ascertain what was the attestation level based on the information that was returned from the EIDLT. So we actually provided a modified RCD passport for the proof of concept, but it could equally be a modified base passport, in which case the information that's conveyed is the enterprise's identity, and it would sign that with its private key. So then when the call is passed to the verification service, the enterprise verification service then it can actually pull the identity information from the DI document, and it would have its public key and the verifiable credential around the identity and if it's been vetted, and the verifiable credential for the TN right to use, and the verifiable credential for the RCD claims as well. So all the information is contained within the one document. And what I must add is actually that the node is co-located with a verification service. So it's an instant response back to the STIAS about the result of that. So the call is not held up. So with that information, obviously, if everything checked, then the shaken attestation can apply an attestation A level, and then that can actually be passed through as a shaken passport and potentially with RCD claims to the TSP that actually then can actually through the STIVS verify the information as well from the RCD, and that's specifically the RCD claims actually for projecting the information to the consumer. And so with that, obviously then, you can project to the consumer handset, that you have a call from a particular brand, and the reason for the call as well. And one aspect that we've not modeled yet, but I think it makes sense, is that, that there's a reputation result that's passed back about the reputation from analytics scores about the those calls that are being placed from certain numbers, so that we get feedback about that as well. But that's something that we haven't looked at yet. So where's the value, and where does this add additional value? So we feel that there's an increase in the integrity around a telephone number, because everything potentially that is on DLT that is verified as the TN right to use. So instantly whether or not someone actually has the right to use that telephone number, and if they obviously have been revoked or that telephone number has been taken back away from them, then everyone knows instantly. There's no static data trying to be refreshed, maybe over end of day period, etc. All of the information is real time, so it increases the integrity in the number if for whatever reason someone's identity vetting has been revoked or not. We increase the value in the telephone number because obviously it's increased that integrity. So we believe that it's increased the value in the telephone number used by an enterprise when they call out to their customer base, and with that it increases then the enterprise's customer acquisition, which makes them more competitive by having this verified engagement with their customer, not only about the number is valid, about who they are and the reason for the call as well. So with all that information, there's a better chance for the consumer actually answering that call than just seeing a verified number on its own. And as I explained earlier, it improves the network infrastructure and switching efficiencies. We did some testing with the DLT and co-located, and we got millisecond responses back, very low millisecond responses back from the DLT in response to verifying the enterprise identity with the credentials. So we're not having to go out to any other third-party entity to pull public keys to actually verify a call. Everything is co-located with the switch. Improving the level of trust and regulatory compliance. As I say, everything that is signed and verified, so a KYC that approved it actually signs the verifiable credential to say that we're the ones that actually approved that entity. So everything, and the telephone number as well, so that the entity that actually assigned the telephone number to that enterprise is signing to say, yes, we're signing to say that we've actually assigned that telephone number. So you've got a level of traceability that's all within the DLT that shows who actually did what, and it's not a proxy of information. It's actually signed by the party that authorized that assignment to happen as well. And it also supports interworking globally. The DLT can span globally, and it would allow the potential for cross-border into working with calls, maybe coming from foreign countries and being terminated into the US as an example. And the last point that I've put at the bottom is that, you know, this can be used for anyone that's maybe even placing a phone call from a mobile device that's just a, you know, a very small business, maybe like a flower shop that is actually conducting their business with a mobile phone, that they can actually have their sign-in wallet for their identity on the mobile device that can actually sign the call directly from the mobile device. So you've actually got then you're lowering the barrier to entry really for all businesses to participate in this type of service. So now I want to talk about how we implemented it in more detail, and in fact more so really I'd like first Orion to probably discuss aspects of this because they actually were instrumental in developing the majority of the proof of concept that we'll show you in a moment there. So Mark, I don't know if you want to talk to this.
Sure. Thank you, Ian. I appreciate this. I realize there's a lot on this slide, so hopefully you can see all of it, and I'll walk you through some of the elements especially. So what we've done here is overlaid the elements in blue onto the standard stir-shaken infrastructure. So you probably recognize a lot of these elements. Some of them may be new to you, so I'll talk you through them. If you think about the diagram, the top north side is the Enterprise Identity Distributed Ledger Network, and there are a number of interfaces for number management. This sort of brings things together that Ian talked about, all the various flows and scenarios. Starting from top left to right, you can see the KYC Vetter maintains authorization via HTTPS. A lot of these interfaces are going to be HTTPS, REST-based interfaces. You can see the Trust Authority that manages credentials for the various players and actors on the DLT. Again, this is a permissioned network, as Ian stated. So Trust Authority's role would be to make sure that only the right parties have access to the DLT and maintain the discretionary access for those parties. Numbering authority would certainly have access as well, as they need to manage the numbering resources. And then you have the TNSP, TNR, and brand. Certainly TNSP and TNR will be involved in the number management on a holistic level, and then brand will be managing its own number allocations. Now, looking at the south side of the diagram, you can see that we have three primary roles here. You have the enterprise caller, right? It could be a brand or the BPO, as Ian described, and that would be responsible for generating the enterprise passport. And the way to do that is using credential management interface, which is again a REST-based interface towards the DLT, and using its private key. And of course, the SIP UA would be the element that's requesting that. And once that's generated, an enterprise passport is created. Enterprise passport is then passed on to the OSP. You can see that in the middle of the diagram. The OSP, in this case, we imagine it would be CSCF. It could be other elements as well, would then pass this information to the Enterprise Identity BS service for RCD. The EIBS would then do verification against the DLT for both the ownership of the phone number as well as the brand identity, to make sure that this brand is capable of able to use the phone number, authorized to use it, as well as that it has the right RCD claims that it's able to use. Once the verification passes, the OSP can apply its local policy to make a number of decisions. Certainly one of them is signing the call with a shaken passport and passing this off to the terminating side. On the terminating side, you have a familiar STIBS function that would be responsible for using, again, a REST interface towards the DLT. And remember, those are DLT nodes are multiple nodes, and they're collocated within the carrier networks, very close to the elements that are actually performing these functions. So you would have both the RCD verification and standard shaken verification, as STIBS would do. RCD verification will be, again, using the number assignment as well as the RCD claims tied to the enterprise identity on the DLT. Once the verification passes, additional decisions could be made via the CVT. You see that on the right through the reputation. As Ian mentioned, that's an element that we are not going to be discussing today, but that's a future phase. And then it would go back to the signaling element again. In this case, it's a CSCF, and then on to the SIP UA on the terminating side. And ultimately, the phone will ring, and the appropriate RCD information will be displayed on the screen, as well as the appropriate shaken information will be displayed on the screen. And I'd like to now move to a little bit of a POC specific infrastructure and pass it off to Julie Fowler. Julie, would you mind taking this on?
Hey, thank you, Mark. This initial proof of concept is going to focus on two things: simulating some of the business process actors that Ian went over, and the second one is a basic enterprise stir, shake, and call flow, leveraging the DLT to sign and verify the call. So we'll have a real SIP call. The interfaces with the DLT are REST API based. One set of APIs is used for business processes, for which we wrote a web interface wrapper that you'll see. The other set is for the SIP call flow. In the demo, you're about to see we use two soft phone clients, one to simulate the originating enterprise, and the other one to simulate their terminating called customer. The high-level call flow starts when our fictitious enterprise.
Sorry. Apologies.
No problem, Ian. The high-level call flow starts when our fictitious your bank enterprise initiates a call, and the first stop is the signing client, which is responsible for generating the RCD identity header. It interacts with the DLT for retrieving the RCD claims and verifying the TN right of use. The originating service provider will interrogate the DLT to verify your bank's vetting status and right to use the telephone number. And it will also create a shaken identity header with attestation level based on those DLT results, which we'll talk about more in a minute. So both of those identity headers are sent to the terminating service provider in this proof of concept, which fully verifies both and performs the necessary SIP header interworking before delivering the call to the terminating soft client. Next slide, please, Ian.
Right.
Thank you. So in the actual demo, we'll simulate the following business processes: the KYC vetting of your bank, authorizing the telephone number right of use, taking back the telephone number right to use from your bank, and then revoking your bank's vetting status altogether. And then we'll go through three call scenarios. The first one is your bank is vetted and with authorized TN right of use. We consider this an attestation A scenario. And on the call device, you'll see, in addition to the calling number, you'll see the calling name, a reason for the call, as well as little green check mark to show that the stir, shake, and verification was successful. The second scenario is your bank is vetted, but it's not authorized to use the telephone number. So we made this a attestation B case, and you'll see the calling name as well as the calling number, but not reason for the call or the little green check mark. The last scenario is when your bank is not vetted at all, and this is considered an attestation C. And so the only thing that we'll see on the called party device is the calling number. And so that's the high level outline of the actual proof of concept. And now I'm going to pass it back to Ian to actually go through the demo.
Thanks, Julie. Appreciate it. Let me just close this down. As Julie said, with two SIP clients here, we've got my bank, sorry, and there's the customer that's being contacted. And actually, I'm going to do a build-up to show basically a new customer, enterprise identity, my bank, that's not been vetted and then been assigned a telephone number that gets us to the attestation A level. And then I'll show that, as the number's taken back, and then potentially that their identity has been revoked, and to show obviously how then the call is no longer authorized and shows attestation C. So as you can see at the moment, we place a call and it's just a telephone number coming through. My bank has not been vetted at all, and they have no telephone number associated to them. So if we bring up here, so we modeled each of the roles, but I could go through them all, but really just in the interest of time I'll show you the KYC vetter. So here we can show the UUID, which we provisioned here actually to show what is the UUID for my bank. And we can see that actually they're not authorized at this point. So we can now vet them, and this is the UUID of the KYC vetter. I'm going to change them now to be authorized. And once that's done, we can see it's authorized and it's updated on the DLT network. It's a Hyperledger network. So I'll just quickly see that now. The status changed. We can see they're authorized. So as Julie was saying, that now because they've been vetted, actually they're attestation B. So actually you can see the my bank coming through, but you don't have the checkbox, which is the full attestation A of shaken at this point in time. So if we go back now, we want to assign that telephone number officially to my bank to use to place calls about a loan application. So if we just look at that telephone number at the moment, we'll see it's actually assigned to the TN reseller and it's open for sale. So we can actually delegate that telephone number. So that's the telephone number. The issuer is the TN reseller, that's the UUID. The holder, which is going to be the holder of this the TN identity now, for the purpose of and so this TN reseller now has assigned that telephone number. We can check that. And you can see here now that the holder of this telephone number is the brand for a loan application. It was issued by this TN reseller and it was issued on. So now we've actually got the telephone number issued. So if we place a call now, we've full attestation A, and we can see that it's my bank calling for the purpose of a loan application. And equally, we can actually take back that number. So we can show if we took that number back, so that TN reseller would be oops. And probably just a quick check. You can see now. So now the holder of that is the TN reseller. You can see here that actually it's not with my bank anymore. So you can see now they don't get the full attestation A with the checkbox. And likewise, if for any reason then there was this my bank was a bad actor, we can actually now change the vetting status potentially to, let's say, revoked in this case. You can see that now. So you can see my bank is revoked. Obviously, if they try placing a call, they don't get attestation B now, it's attestation C. So there's just no information about this caller. So that's the it's fully operational on a lab environment, as Julie was explaining. And if anyone's interested, be happy to show more details behind that, all of the workflow and from the business model that we were showing earlier about the authentication, right from the trust authority down. But just in the interest of time, I just go back to presentation. So where are we at now? So probably from, as I say, when we started this, we published the ATIS 76 document, which is the use cases. We agreed the scope of the phase 1 of the POC, which you've seen now. We've implemented technology standards around the W3C, self-sovereign identity. We developed and delivered that POC, which is available now. We also actually updated the ATIS 10089 to include the DLT as an option for enterprise attestation. So there's a version 2 now of the ATIS 10089 with that information in it. And actually, we're just about to publish another ATIS technical report, which is actually the full details of how the self-sovereign identity and verifiable credential are defined for implementation of the enterprise identity and the telephone number identity and all the verifiable credentials for vetting, RCD claims, and TN authorization as well. That's just in final edit, so that should be available on the ATIS website next week. So take a note of the number and look for it next week. It should be available. And so the next phase, what we're looking to do is actually look at validating interoperability of the W3C standards with other services. So it could be for other telecom services. It could be for interoperability with other demographics, other organizations that are wanting to actually validate cross-border telephone numbers, and enterprises as well. So that's going to be the next phase, the phase 2 of this work. And any questions? So I see we did have a number of questions there posted online. Now, Mark, I don't know, did you see any questions there that you'd like to take?
Sure, we could just start maybe from the top and go from there, if that works for you, Ian. So I believe the first question is, what is your biggest obstacle in end-to-end execution of this modern technology solution to the StarShaken initiative? That's kind of an interesting question, right? So I think the biggest obstacle, I'd say, is the fact that the DLT technology is often misunderstood. And I think Ian's done a great job explaining that DLT and Bitcoin are not the same thing, right? DLT is a very different beast. They may share underlying technology that's the same, but ultimately it's a very different permissioned private network as opposed to a public network, and specifically targeted towards reporting information that has a need to have a ledger or some other source of non-repudiation and also non-volatility. So I think that'd be the biggest item, I think.
I think so, and I think that when we did the poll question there about what experience people had with working with DLT today, whether that was privately, through doing any cryptocurrency investments, and even at that, that's not to say that they actually understand blockchain technology itself. So I think that there's some education around some of the myths of blockchain, and certainly we see it in the press all the time about burning rainforests to actually mine Bitcoin. And I think that what we're talking about here is enterprise permission blockchains that actually don't need to actually burn that level of power for the consensus mechanism to function. So it's very different, but certainly taking on board that people probably don't have experience of what is the capabilities of DLT using its cryptographic techniques, and again around self-sovereign identity and the power of that, and how flexible that can be to actually proving within a single, let's say, source of truth within the DLT, that everything that's signed is actually on the DLT, so you're not having to go around to actually try and pull all this information together from different sources for traceability, which we talked about earlier. So certainly I think that, yeah, there's some education required for people to understand how it can apply to this type of service.
Okay. The next question I thought was interesting. Question, I am not entirely familiar with the DLT topology. I would like to know if there is a semi-public format where, for example, it is a government-controlled entity providing the ledger, for example, for a country, and there could be multiple blockchains in different countries, but all separated by a regulatory framework. Do you want to take this one, Ian?
Yeah, so look, all those are possible. We talked that you've got completely public blockchains that are kind of organic, and they're sort of managed by the participants, that like the Bitcoin. You've also got enterprise specific blockchains that only are used for a specific maybe application. And certainly, there are government blockchains. We're seeing in the EU now that the EU has actually built the whole EU citizen identity on a private blockchain. So that's available now for EU citizens to actually be able to prove their identity across all borders in the EU. So they can actually go from France to Germany to Spain and Ireland and show their identity, and it can be validated in each of those countries. So that's a good example of cross-border sort of interoperability. And certainly, there are a number of standards being worked on, even by IEEE, about blockchain interoperability as well, so that different blockchains, maybe from different organizations, in this example, maybe different governments, how they can interoperate as well. And certainly with self-sovereign identity, because you actually have, as part of the identity of it, the first part of it is the namespace. So it's actually which DLT is actually my identity part of. So that would work for people that are roaming. So you could have DID, which is the first part that shows that it's a DID identity, and then dot, and it could be US shaken, or it could be GB shaken, and then the UUID. So the first part is really the namespace, so that the carrier knows where to pull that information from if let's say someone potentially roaming into your network and you wanted to validate them, as an example.
Right. Okay. Any comments, Julie? Anything you want to add?
For that one, no. Nothing for that one. I did see one question. It seems that DLT is used for storage and access of the certificates resulting from the provisioning and vetting process. Is the validity of certificate still needed to chain up to a centralized identity, say the STI-GA? So Ian may want to weigh on in this one, but in the proof of concept, all of the information that's needed to verify the call, the vetting status, and everything is on the DLT in terms of confirming, the identity and the RCD claims, etc. But what is used in the proof of concept certificate perspective is signing the RCD passport. And Ian probably wants to weigh in on this one. Oh, we may have just lost him.
There we go.
But in the proof of concept, for signing the RCD passport, we use what would be considered a regular GA cert. But the public key is actually stored on the DLT. So the location of the public key is actually in the DLT itself. And and the location, of course, is carried in the RCD passport. So, Ian, you may want to elaborate on what that's going to look like in the second round in the future, but.
Yeah, so I mean, yeah, you're right. So I mean, it's not in a typical PKI infrastructure using X509 certs. You're using a public-private key pair that are generated when the identity is generated, but you have the ability to refresh those keys as well. So you can actually update them, obviously for security as well, and so anyone that's actually signing any information and their identities on the DLT, you can actually see the public key for who those identities are that are actually signing those proofs on the DLT. So it's a different sort of structure. You know, you're not having to actually go through these hierarchical sort of CAs to actually find the root of trust, because it's with SSI, it's very different. The end entity is in control of their own identity, and actually how they actually and how often they would like to cycle their public-private key pair that's associated with that. So it emulates some of the security of recycling certificates, but as you said, all of the public certs are actually on the DLT itself.
Thank you, Ian. There's another question, actually quite a few questions on vetting, which is really interesting. So this is a question, will you be vetting RCD claims also, logos, names, emails, etc.? Can this be extended to individuals, or is it meant just for the enterprises? Let me maybe take a stab at it, Ian, and then you and Julie maybe can help me a little bit. So the first part of the question is, are the RCD claims also vetted? The answer is yes, they are. This is the function of the KYC vetter. Along with vetting the enterprise itself, they can also be vetting RCD claims. It's obviously very important to make sure that those are proper for a number of reasons. And that does include logos, emails, names, whatever is appropriate for the display, reasons for the call, names, display names, etc. The second part of the question is even more interesting. Can this be extended to individuals, or is it meant just for the enterprise? And I think this is a great topic, Ian, and probably more time than we will need more time than what we have left. But I think the short answer is certainly yes, even though I think our current phase sort of is limited to the enterprises because we think it's more interesting use case. Anything to add, Ian or Julie, on this?
Yeah, I mean, certainly I feel that with this technology, because as I mentioned that, you can actually have a wallet on the mobile device. So it could actually be, for a small business entity, obviously they have to go through the same KYC vetting process to prove that the number that they're using is that business behind that. It is the flower shop, whoever that brand name is, and they'll still have to go through that KYC vetting process. But it could be that, yes, certainly it could be used for individuals even, which is, even if individuals were calling a bank, for example, and we've seen a lot of phishing of people's personal information and people actually spoofing them to call in a bank to maybe get new passwords, reset, etc. Certainly you can see how this technology, could be used for actually personal verification of a telephone number to prove it's that individual that's calling the bank. So the bank then has the security to know that it's actually you that's calling them. One interesting point that maybe I didn't mention earlier, which when we're talking about KYC vetters, that's a function. We're not saying it's a business entity. That function can reside within the mobile carrier or the fixed line carrier. So if they do their own KYC vetting, which we saw there on the poll, 50% of them actually do that. So that function already resides within the carrier themselves. So they would actually be that function as well. So it's a function. We're not saying it's a separate business from the OSP or TSP or the carrier. It's actually just a function. So it sounds like that, if most people do that internally, they're going to actually be performing that function.
Guys, we've reached the end time. I know you could probably talk for another hour on this. It was quite fascinating, actually. And there were a lot of comments coming in from folks. One just came in that said, awesome demo, for example. So
thank you very much.
Thank
A
you.
lot of folks that were, very surprised that it's come so far along. So very well done. Thank you. Thank you, Mark and Julie. Thank you, First Orion, for supporting our virtual event as a Diamond sponsor. Very much appreciated. Thank you. Before I close, I just want to alert folks that in about 1 hour, we're going to get an update on the status of the STIR/SHAKEN STI GA. So I hope you all join us for that. And with that, I wish you all a great rest of your day. Thank you so much.
Thank you, Mark.
Bye-bye now.
Thank you, everyone. Thank you,
Take
Mark.
care.
Bye.